Welcome to Defenders, the teaching class of Dr. William Lane Craig. Today, The Existence of God, Part 8. For more information and resources, go to reasonablefaith.org.
Let's go now to our lesson, which is on the Kalam Cosmological argument. And we've been talking whether or not an actually infinite number of things can exist. You remember the Muslim medieval theologian Al-Ghazali argued for the creation of the universe and the existence of a creator by saying that if the universe is beginningless, if the universe never began to exist, then there has been an infinite number of past events prior to today. But, he argued, an actually infinite number of things cannot exist. That leads to absurdities. Therefore, that implies that the number of past events must be merely finite, and therefore the series of past events doesn't go back forever. There must have been a beginning. And given that whatever begins to exist has a cause, it would follow that therefore there is a transcendent cause of the universe that brought it into being. Now, before we look at the second philosophical argument that Al-Ghazali gives for the beginning of the universe, let me ask if there's any questions left over from last week about what we shared with regard to the existence of an actual infinite. And can we get the mic here so we can get the question on mic? Right, the dates, you mean of when he lived? Right, I don't know his birthday, but I think he died around 1111. So he was a 12th century Persian, lived in what is modern-day Iran. Any other question from last week? All right, well, Al-Ghazali has a second independent argument for the beginning of the universe. So if one wants to maintain that the universe is eternal in the past, he'll have to refute not only Al-Ghazali's first argument, but this second one as well, because this is an independent argument. It doesn't depend on the first one for its cogency. And this argument goes like this. Al-Ghazali says the series of past events going back in time has been formed by adding one member after another. The series of past events is like a series of dominoes falling one after another until the last domino, which is today, is reached. But he says no series which is formed by adding one member at a time, one after another, can ever be actually infinite, because you cannot pass through an infinite number of things, one member at a time. Now, sometimes this is called the impossibility of counting to infinity. In the case of trying to count to infinity, I think it's very easy to see. No matter how high you count, you'll never reach infinity, because there's always another number first that you would have to count before you could get to infinity. There is no finite number which plus one will land you in infinity. You can always count higher, and so it's impossible to count to infinity. But now think about this. If you cannot count to infinity, how could you count down from infinity? If you can't count to infinity, how could you count down from infinity? This would be like someone's claiming to have counted down all of the negative numbers, -3, -2, -1, ending in 0. And this seems crazy for somebody to say that you can count down all of the negative numbers one at a time, ending in 0. For before he could count -1, he'd have to count -2. But before he could count -2, he'd have to count -3. Before he could count -3, he'd have to count -4, and so on and on and on, back and back, before any number could be counted. An infinity of prior numbers would already have to have been counted first. So you just get driven back and back and back into the past, so that no number could ever be counted, no number could ever be reached. But then the final domino in the series could never fall if an infinite number of prior dominoes had to fall first, so that today could never be reached. But that's obviously absurd, because here we are. We are at today. It has been reached. And so this shows that the series of past events must be finite and have a beginning. So that's the argument. Now, before we look at a possible objection, is there any comprehension type question that anyone has about this argument?
If there can't be an infinite past, can there be an infinite future?
If there can't be an infinite past, can there be an infinite future? Remember, we talked about this either last week or the week before and said this depends upon your view of time. If you hold to this view of time, which is often called the A theory, according to which the future does not exist, it is pure potentiality, then the future can be infinite in the sense that time can have a beginning and the series of past events can go on forever. It is potentially infinite. So it would be infinite in the sense we talked about of potential infinity. In this case, it will never arrive at infinity. There will never be a future event, the infinitieth event, at which you will arrive. So, no, the future will not be infinite in that sense. It will be merely potentially infinite. So, from any point in time you pick, it will be a finite distance to the beginning, and the distance going forward will be finite but potentially infinite in the sense that infinity serves as a limit. Now, if you adopt a B theory of time, according to which past, present, and future are all real, they're stretched out like a line, well, in that case, this argument would imply that time must have a beginning and an end, because you couldn't have an actually infinite amount of time. Yes, which is more plausible? Well, Al-Ghazali holds to an A theory of time. The people who hold to this argument hold to an A theory because they think that the way the past has been formed is not just by existing like a line. It comes into being one event at a time as one event occurs after another. And that is certainly the common sense view of time. This is the way we experience time, and I see no reason to think that that experience is illusory. I don't think we're suffering under some sort of gigantic delusion that temporal becoming is real when in fact it's not. So I am a pretty ardent supporter of this so-called A theory of time, which says that temporal becoming is a real and objective feature of reality. When we talked about divine eternity, we talked about this a little bit too, and I pointed out there are certain theological problems too with the B theory that the A theory doesn't share. So look back at that section of the class again when we talked about God's attributes and his eternity, and we discussed these, because this will directly impinge on how we understand God's relationship with time. Yes, Bob?
Just go back over the B theory again. Some of us missed the B theory.
The B theory says that the difference between past, present, and future is illusory in the sense that it's just a feature of human consciousness. For the people in the year 2000, 2000 is now and 2010 is future. But for the people in 2010, 2000 is past and 2010 is future. And for the people in 2050, both 2000 and 2010 are past and 2050 is present. So on this view, what is present, future, or past is just a subjective point of your standpoint. It's very analogous to, in space, talking about what is here. There is no objective place that is here. Yeah, it's just your subjective standpoint. So if I were in Turkey, I would say, well, Istanbul is here. But if I'm in Atlanta, I say Istanbul is there and Atlanta is here. But there isn't any objective here or there. There are just these spatial locations. And similarly, B theorists would say all of the moments in time are just stretched out like a line. They're all equally real. And what you say is now is just the point where you are on the line. And the future is what's later than that, and the past is what's earlier. And there is no privilege now. Everybody thinks that his point is now. Is that clear? So it treats time very much like space. It thinks of time as just kind of there as a whole, like a spatial line, and then what is now or present is very much like what is here. And so there's a very close assimilation of time to space on this B theory. Yes, okay, here, Elizabeth.
With the B theory of time, if every time exists equally, like it exists all at the same time.
Yeah, so you can't say all at the same time. That's
Exactly.
Your language trips you up.
Right.
But yes, they are all equally real and existent.
So, but that means that I exist in 2000. That means I'm a different person? Am I the same person?
You are raising a very, very profound question about personal identity over time. And what these B theorists, I think, have to say is that you are not a three-dimensional object that exists now. You are a four-dimensional object which is spread out through time. Sometimes this is called a space-time worm. You have temporal extension. And what we see now is not really you, Elizabeth. We just see a three-dimensional slice of you. You are actually stretched out in time, and we see a slice of you right now. But that's not the same slice that exists, say, 2 hours from now. That's a different slice of you. Now, the difficulty is, if that's true, that means you're not the same person that came in here a few minutes ago. You're somebody else. That slice is still back there, and you're someone else. So if we say that what we are seeing now is persons, that you're a person, then it follows that no person endures over time. I said this creates theological problems. How can then God judge the slice that exists at Judgment Day for the deeds done by some other slice earlier on in time? Why should he get the rap for what that earlier slice did? I mean, this is a real serious problem. Now, if you say, well, no. Persons are not these three-dimensional things, these slices. The person is the whole four-dimensional worm. Well, then that means that persons are not conscious. They don't do anything. They have no will, because that worm doesn't have any self-consciousness, right? Just the slices do. And that's not what we mean by a person. So you have pulled a thread here, in the fabric that I think really makes this B theory difficult to hold. Okay, yes?
Well, I know this little, side trip on the time theories is a little different than what we were talking about. I thought of something that I seem to recall reading in one of your books, but I can't remember how you answered it. And I was recently raised again when I read a book by Brian Greene. He talks about how relativity theory pretty much creates a space-time loaf, as he calls it, and brings up certain questions such as, well, the idea of maybe linking different times, things like that, and how you would explain, since we all pretty much have different clocks ticking at different rates, and using Newton's sort of absolute space doesn't seem to work in modern.
What he's raising here is the argument that many B theorists give is that relativity theory requires that we have this B theory of time, or as you put it, a loaf that can be sliced up. See, that's the same as the worm metaphor, and you slice the loaf into different slices. What I would argue, and I have argued in my written work, is that, a number of things. There can be a privileged reference frame in relativity theory. That is to say, a preferred frame, which does record the absolute time, and these other measurements of moving observers are simply due to the distortion of their instruments. Moving clocks run slow, measuring rods in motion shrink up, and therefore they don't detect the true time, which could only be given by someone who's at absolute rest. And I think that interpretation of relativity theory is entirely adequate, and there's a number of physicists who hold to it. The other thing is to say, this whole debate is academic because the special theory of relativity is transcended by the general theory of relativity anyway. The special theory just deals with objects in uniform motion, but it doesn't deal with accelerated motion or rotational motion. That's the general theory. And when you talk about the general theory of relativity, then what happens is that a preferred time called cosmic time does come suddenly into play, and cosmic time is the time that scientists use to measure the duration of the universe as a whole. So when you hear scientists say it's been 13.7 billion years since the Big Bang, what they're talking about there is cosmic time. That is the time that measures the duration of the universe. Now, fortunately for us, cosmic time coincides very nicely with Earth time, so that our clocks do provide a very good measure of cosmic time. So we can say it has been about 13.5 billion years since the Big Bang. So let me just, since this is a sidetrack, let's end it with that and go to Cindy's question.
And, when you think of God being omnipresent in time, and, being involved in the whole universe at any point in time, yet on the A theory, is it that he entered time so that there was a sequence of events, rather than the God that was there at pre-Jesus' birth to the God at his point in death to the God today being omnipresent? He didn't change in the sense of he wouldn't have in some way be a different entity. In other words, he's the same at each point in history, yet he did take on a bodily form and enter time at that point.
Well, that's the view that I defended, Cindy. If you think back again to the section of the class when we did the attributes of God, and we talked about God's eternity, the view that I defend is that God existing alone, without creation, without the universe, is timeless. And he creates the universe at the moment of the Big Bang. And in so doing, he enters into time in order to have relationships with the creation that he has made. So the way I put it is that God is timeless without creation, and he's in time since the beginning of creation.
Which is consistent with the B theory.
Well, that's consistent with the A theory, because...
the A theory.
Yeah, it's consistent with the A theory because time would have a beginning, and we could go back. There's a finite number of events that takes you back to the first event, the first moment of time, and then beyond that, not before it, but causally beyond that would be God in his timeless eternity, and he would be the creator of time and space. All right, any other question about this argument that you cannot have an infinite regress of temporal events that have been formed by adding one member after another? All right, well, let's consider a possible objection to this argument. Some critics have responded to this argument by saying that in an infinite past, there is no event infinitely distant from the present. It's not as though you have to traverse the distance between an infinitely distant event in the past and today. Rather, there is no beginning point at all, not even an infinitely distant one. But every event in the past is only a finite amount of time from the present. You could give the analogy of the negative numbers. In the negative number series, there is no number that is minus infinity. But every number you pick is only a finite distance to 0. So whether you pick negative 10, negative 1 million, negative 10 trillion, there's only a finite distance to the present, or to 0, which can be easily traversed. So if the past is infinite, these critics say, there is no infinitely distant event from which you have to reach the present. And from every point in the past, it's only a finite distance to the present, and therefore there's no problem. Now, it seems to me that this objection commits a logical fallacy, which is called the fallacy of composition. The fallacy of composition. Now, what's that? Well, the fallacy of composition is the fallacy of equating a property of a part of a thing with the whole thing. Saying that because a thing's parts have a certain property, therefore the whole thing has that property. So, for example, it would be like saying that because every part of an elephant is light in weight, therefore the whole elephant is light in weight. And that's obviously a fallacy. Every little piece of an elephant that you might pick might be light in weight, but that doesn't imply that the elephant as a whole is light in weight. See, the fallacy of composition is ascribing the property of the part to the thing as a whole. And that is fallacious reasoning. Now, what about the case in hand? just because every finite part of the series can be crossed or counted down doesn't mean that the whole infinite series can be crossed or counted down. So these philosophers have committed an elementary logical fallacy. They think that because every part can be counted or traversed, therefore the whole can be counted or traversed. And that commits the fallacy of composition. The question, after all, is not how can any finite part of the past be crossed to reach today. The question is how can the whole infinite, beginningless past be crossed in order to reach today? Any comment or question about that objection and my response to it? All right, well, let me share two more absurdities with the idea of an infinite past that Al-Ghazali gave to round out this argument. Al-Ghazali tried to show you can't form an actually infinite past by adding one member after a time. But suppose it could be done. He gives this illustration. He says, let's imagine that for every one orbit that Saturn goes around the sun, that Jupiter goes around 2 times as many. So if we imagine Saturn here orbiting the sun, and Jupiter is closer in, so for every one orbit that Saturn goes around the sun, Jupiter goes around the sun 2 times as many. So the longer they orbit, the farther and farther Jupiter falls behind. If Saturn goes around 4 times, or rather if Saturn goes around 2 times, Jupiter has gone around 4 times. If Saturn goes around 1,000,000 times, then Jupiter's gone around 2,000,000 times. They're in a 2-to-1 ratio. So the longer they orbit, the farther and farther Jupiter falls behind. In fact, if they were to orbit forever, what would happen? Well, Jupiter would approach a limit at which it would be infinitely far behind Saturn. If they go on orbiting forever, it would be infinitely behind Saturn. Now, says Al-Ghazali, turn the story around. Let's suppose that they have been orbiting the sun from eternity past. Now, which one will have completed the most orbits? Well, the answer is that the number of orbits is exactly equal, namely infinity. They both completed an infinite number of orbits. Now, don't let somebody try to get out of this by saying infinity isn't a number. Infinity is a number. It is the number of elements in the set 0, 1, 2, 3, and so forth. Infinity in modern mathematics is a number, and it would be the number of orbits completed by each of these planets. And yet that seems absurd, because the longer they orbit, the farther Jupiter falls behind. So how are they now magically equal in virtue of the fact that they have been orbiting for infinite amount of time from eternity past? Here's another illustration Al-Ghazali gives. He says, suppose we meet someone who claims to be counting down from eternity past, and he's now finishing. -3, -2, -1, 0. He's done with his infinite countdown. Now Al-Ghazali thinks, well, why did he finish his countdown today? Why didn't he finish yesterday? Or the day before that? Or the day before that? If he's counting at a rate, say, of 1 number per second, at any time in the past, he's already had an infinite number of seconds to finish his countdown. So why did it take him so long till today to get through? He should have already finished. In fact, at any point in the past you pick, he's already had infinite time to finish his countdown, so he should have already finished. But that means that no matter how far back in time you go, you can never find the man finishing his countdown. And that contradicts the hypothesis that he has been counting down from eternity, which, again, just shows the absurdity of trying to form an infinite past through adding one member after another. And I think these illustrations really underline Al-Ghazali's claim that in the case of a series which is formed by adding one member after another, you cannot do this and have an actually infinite series. This is only possible with a finite series. So, any question about either of those two illustrations or discussion about any of those? All right, well, I think those then give us good grounds for, again, the second premise of the Kalam cosmological argument, that the universe began to exist. So now we have two philosophical arguments for the finitude of the past, one based on the impossibility of the existence of an actually infinite number of things, and then the other based on the impossibility of forming an infinite collection by adding one member after another if it is actually infinite. And so for both of these reasons, I think we have good grounds for thinking the second premise is true. Now, when we come together again, what we'll look at is remarkable scientific evidence in support of this second premise that the universe began to exist. In the Middle Ages, Al-Ghazali only had philosophical arguments. What has breathed new life into the Kalam cosmological argument is that we now have pretty strong astrophysical evidence that the universe is not eternal in the past, but had a beginning a finite time ago. And that is what we will look at then next time.
The copyright for the content of this recording is held by Dr. William Lane Craig. For more, go to reasonablefaith.org.